hey guys, welcome back to my channel, and today we will be discussing another question from GATE 2025 paper, the CS2 paper, the second shift of this paper. And the question says, processes P1, P2, P3 and P4 arrive in that order at times 0, 1, 2, 8 milliseconds respectively and have execution times of 10, 13, 6, 9 milliseconds respectively. Shortest remaining time first algorithm is used as the CPU scheduling policy. Ignore context switching times. Now we have to tell from the following which one of them gives the correct average turnaround time of the four processes in milliseconds. Just for a quick recap for you, the shortest remaining time first algorithm is about giving CPU cycles or allowing the process to run on the CPU which has the least remaining time, the least remaining execution time at that point of time. Turnaround time. Turnaround time for a process is the time at which process ends minus the arrival time. Like the amount of time for which the process stays inside the CPU, whether it's running or not running. This is our turnaround time. So at t equals to 0, we see we have only one process at t equals to 0 because P2, P3, P4 arrive later. So at t equals to 0, we have P1 running. So P1 will run from T0 to T1. But now we see that P2 also arrives at 1 second. But the remaining time for P2 would be 13 seconds, while P1, since it has already run for a second, the time remaining would be 9. So P1 will keep on running till t equals to 2 seconds. Now, when it comes t equals to 2 seconds, we have P3. Now P3 has 6 milliseconds of total time remaining. But P1, which was already running, would be having 8 milliseconds of time remaining. 10 minus 2 and 6 minus 0, of course. So we will give the CPU to P3 from t equals to 2 to t equals to 8 because it is of 6 seconds. And the next process arrives at t equals to 8. Another point, during this duration, we are not giving CPU to any other process because the remaining time for all other processes besides P3, that would be P1 and P2 during this duration, would have more remaining time. So at t equals to 8, our P3 process would be over. And now at t equals to 8, another process P4 would arrive whose remaining time would be 9 milliseconds. So we at t equals to 8, we would have P1 having 8 milliseconds remaining, P2 having 13 milliseconds remaining, and P3 having 0 milliseconds remaining, and P4 having 9 milliseconds remaining. Now from this, can you tell which process we would choose? Now, so from this we can say clearly P1 we will be choosing for next run. So P1 will get the CPU again for 8 more seconds. We will get to have P1 running again till t equals to 16. Now at t equals to 16, this thing will become 0. This will remain 13, this again 0, and this will be 9. Now from this, we can say P4 will be the next in line. So since P4 has the least remaining time at t equals to 16, P4 will get the CPU till t equals to 25. Please don't judge by the sizes of these blocks and the time, the magnitude of time. So this is just for your reference and visualization. And at t equals to 25, the P4 would also become 0. And P3 will be 0, P1 will be 0, and we would be having P2 with 13 seconds remaining. So P2 will get to run last on the CPU. So at t equals to 38, our P2 would also be over. So from this, can you tell me the turnaround time for each process? So let's see for P1. P1 ends at 16 and it arrived at 0 seconds. So 16 minus 0 would be the turnaround time for P1. Now, if we see for P2, P2 arrived at t equals to 1 and it ended at t equals to 38. So it would be 38 minus 1. This will be our P2. Now if we go on looking for P3, this is our P3. This is our P3. P3 arrived at t equals to 2 seconds and it ran till t equals to 8 seconds. So 8 minus 2. This is t. And now if we look for P4, which is this yellow process, it arrived. It arrived at 8 milliseconds and it ended at 25. So we would be doing 25 minus 8. If we divide this entire thing by 4, because we have a total of because we have a total of 4 processes, we would be getting 16 plus 37 plus 6 plus 17 upon 4. And we would see this will be roughly equals to 76 by 4, giving us 19 milliseconds as the average turnaround time for these processes. So D option becomes the right answer for this question. So if you liked what I shared in this video, do like this video. Please share it with your friends who are also preparing for GATE. And don't forget to subscribe the channel if you want more videos like this. And do press the bell icon if you want to get notified about these updates. So thanks for watching this video.